today's topic is ethers. Ethers are organic compounds that consist of two organic radicals that are bonded to the same atom of oxygen. What do I mean by that? Let's look at an example. Ethers used to have a general formula of ROR. These R represent the organic radicals that are bonded to the same atom of oxygen, or you rather write it as ROR. Ethers are of two classes. We have the symmetrical and the unsymmetrical ethers. These symmetrical ethers, they are ethers that contains organic radicals, identical organic radicals, two identical organic radicals. Example of such is when we have ethoxyethane. Ethoxyethane consists of one of the R to be C2H5 connected to oxygen, connected to another C2H5. So it is termed ethoxyethane. We also have other ones called methoxymethane and so on. Provided these two organic radicals are identical, they are called the symmetrical ethers. Then the unsymmetrical ethers are ethers that consist of two different organic radicals. Example of such is methoxybenzene. Methoxybenzene is one of the unsymmetrical ethers. The structure gives actually ethers is given a structure of this nature. So this is methoxybenzene. The nomenclature for ethers are much more simpler compared to all other homologous series. Why? Because it is very easy. Once you call the last organic radical here oxygen, then you call the first one. So as we have ethoxyethane, as we have methoxybenzene, and so on. So other ethers that has a longer chain, we are going to use the special naming system for them. As for example, we have CH2, CH3, CHO, CH3. So in naming this, we have to give it numbers 1, 2, 3, 4. CH3 here, CH2 here. Correction. So this is called 2-methoxy. Then we have 4. That's butane. Because the oxygen is termed to be in the number 2. So that's 1, 2, 3, 4. That's 2-methoxybutane. 2-methoxybutane. So that is the nomenclature. Other chains can also be named in the following trend, and will be gotten well. Of ethers. Ethers is prepared by two methods. The first one is the dehydration of alcohol. The dehydration of alcohol. This is achieved in the presence of H2SO4. When an alcohol is heated up in the presence of H2SO4, there is production of ether, and this is the mechanism of the reaction explains that 1 mole of water is removed from 2 moles of the alcohol to produce ether. Let's take for example, when we are producing ethoxyethane, C2H5, that's 2 moles of ethanol will be used. So these 2 moles of ethanols, 1 mole of water will be subtracted from it to produce C2H5 or C2H5. So this is a method called dehydration of alcohol used in preparing ethers. Then we also have the second one called the Williamson. The Williamson's ether synthesis. The Williamson ether synthesis is another method, the most widely used method in producing ethers, and this is achieved when an alcohol is mixed with sodium to produce alkyl oxide ion. So the alkyl oxide ion is then reacted with alkynes to produce ethers. Let's take, for example, the production of ethoxyethane again. So we have C2H5 used, OH, ethanol, plus 2 moles of sodium to produce C2H5O. So this is the alkyl oxide ion because the sodium has snatched an hydrogen from the chain to form the alkyl oxide ion plus 2Na plus H2. Hydrogen gas is also produced because 2 hydrogen is removed from 2 moles of ethanol to produce H2, then alkyl oxide ion. So this alkyl oxide ion, C2H5O, is then reacted with halogenoalkane. Halogenoalkane means an alkyl member connected to the halogen. Example of such is iodoethane. Iodoethane is C2H5I. C2H5I. So when these are reacted, iodine was produced as an ion and the 2 radicals are connected to the oxygen. Then we have C2H5O, C2H5 plus iodine. So this is another method of preparing esters. These are the 2 major methods for the production or preparation of ethers. So now let's look at the type of reactions ethers undergo. Or the type of reaction ethers undergoes. Ethers are generally not active. They are not reactive. But however, they undergo only one type of reaction, which is called the cleavage reaction. The cleavage in the sense that they can be converted from ether to another compound, which is always halogenoalkanes. How is this done? When ethers, example of such is C2H5OH or C2H5 again, is reacted with an halogenoalkane, like C2H5 is reacted with hydrogen iodide. Or phosphorus pentachloride, not halogenoalkane. There is a production of C2H5I plus H2O. The ether, which is ethoxyethane, will be acted with 2 moles of hydrogen iodide to produce 2 moles of iodoethane plus 1 mole of water. This is achieved when the oxygen is removed and replaced with iodide, 2 moles of iodide, and 2 moles of hydrogen or 1 mole of hydrogen molecule left is reacted with oxygen to produce water. This is the major method used in preparation in the type of reaction ethers do undergo, or another method of producing halogenoalkane, the other way around. So we can also produce halogenoalkane using a second example, using another reagent other than hydrogen iodide, which is a PCl5, that's phosphorus pentachloride. So like, let's take an example of this is methoxybenzene plus phosphorus pentachloride. The end product of this reaction becomes phenol, so this is one of the methods. When phosphorus pentachloride is used, we have the production of phenol and we have the production of ethylene dichloride, and we have the production of phosphorus trichloride. So this marks the end of the topic, heaters. Please subscribe to our YouTube channel. We'll bring you more videos. Thank you.